Hi, everyone. We're back for more. We already did day 6. This is Mrs. Robinson again, day 6 of Exponents, and now we are on to day 7 of Exponents. More power. So we're going to get a little bit more complicated today. So let's do this. So number 1, again, we can do the FOIL process and solve that one. So pause the video and try that one out. Should have gotten D. And number 2, how can we determine which expression would make the following statement true? So what I do is I take what I know and see if I can eliminate any choices. So 16 divided by what would give me 4? Well, 16 divided by 4 would give me 4. So let's see what we can take out. We can take away D and B as our choices. And now we have 2 choices, A and C. So looking to see how we could solve and get the rest of this. So x to the 4th and x what would give me x to the 3rd? Well, the x, it would just have to be x to the 1st in order to get x to the 3rd. So your answer would be A. All right, so 1 would be D, 2 would be A, and let's move it along and try these problems out. So we're first going to try power of a power property, power of a product property, so we're going to write down that information. Get this paper ready. All right, power of a power. So this is a to the m times to the n power. So am to the n power. So let me give an example of that. So that answer would be am times n, or amn. Okay? So let's give an example so then you can kind of understand what this means. So if I had x to the 3rd to the 2nd power, that means I would have 2 x to the 3rds, which would mean I have x to the 6th. So instead of doing that every time, I can multiply the 3 times the 2 together to get to x to the 6th. Power of a power. So there's power on the inside of the parentheses, and then it's to a power. Oh my gosh, all that power. Now let's do power of a product. So let's say that I had an A and B inside, AB inside, to the M power. Well, that means that A to the M and also B to the M. Both of them need to have that exponent. So again, let's give some example to that so then you can kind of understand what I'm talking about. So I have xy to the 3rd, which means I have 3 xy groupings, which would mean x to the 3rd and y to the 3rd. So think of it as I am taking this power and giving it to everything on the inside. Okay, so let's try number 1. So this would be 3, so it would be 2 times 2 to the 3rd times 3 2 to the 3rd times 2 to the 2nd power. Okay, woo! So 2 to the 6th. So 3 times 2. All right, the next one would be x to the 12th, multiplying them together. And then let's try this one. So I have a 3 on the inside, y to the 3rd to the 5x power. So y to the 15x. All right, so I'm going to do the first 2 with you, and then you'll try the last 2 on your own. So number 4. So I'm going to have this to the 8th power, and I'm going to have to give it to everything on the inside. So I have negative m to the 56th to the n to the 8th. So m56, n8, and then we bring down that negative. All right, the next one. Again, we have to do everything in the parentheses first. We're not going to deal with the 4 just yet. So I have 3 squared x to the 10th. And then I have it times the 4. Okay, well, 3 to the 2nd is 9. And I have that times 4, so that is 36x to the 10th. Please make sure you do everything with the exponents in the parentheses before you move on to the outside. All right, so the next 2, I want you to try on your own and see how you do. All right, the next one is negative 9. Oh, sorry, number 6. You had negative y to the 4th. There was nothing to do on it. There was no x. There was no parentheses, no power of a power to do. And the negative stays because there was nothing to do with it. All right, number 7. Negative 9, x15, y18, z cubed. So that would be your final answer. So first, dealing with each of the parentheses on their own. and then combining from there. So first I have to do multiplication, and then I would add the exponents once we got rid of the power of the power. All right, let's move along to the next one. All right, now we're going to deal with quotient of a power. So instead of the power of a power, we now have quotient of a power. So if I have a division problem, I have a to the m over a to the n, that means I'm going to be subtracting the exponent. So how many do I have? Okay, and then power of a quotient. So whenever you hear power, think of parentheses. So product, multiplication, quotient, division, power, we're talking parentheses and how that comes up. So x over y to the m power, which would equal x to the m and y to the m. So let's try these rules down here. So I have 7 to the 9th and 7 to the 5th. So how many 7s do I have left over? I have 4, because it's 7 to the 9th minus 4. Okay, all right, let's look at number 9. Okay, coefficients are separate from our actual powers, our bases. Okay, so I have 8 over 2. I would just divide as such, which would become 4. And now let's look at that power. So I have m to the 7th and m to the 3rd. So what's 7 minus 3? M to the 4th. Okay, so you want to separate the coefficients and all of the powers, okay? Because then they're each separate. So like, let's look at number 10. So we can even separate it so we can see them each on their own, kind of give you a better visual to see what we're working with. Oh, let's change the color. Magic! I got the magic. Okay, we got the power. I have so many different songs. Okay, negative 3/9. Let's reduce that. So that would become negative 1/3. All right, w to the 6th over w to the 5th. Okay, we have one w left on the top. And the very last one, x to the 4th over x to the 6th. All right, I have 2 x's left, and that's on the bottom. So this would be my final answer. I wouldn't really need a 1 as a placeholder. So I'd have negative w over 3x squared. The negative can be on the top or the bottom. It does not matter as long as it's part of the fraction. All right, now it's your turn. So I'm going to do 11 and 12, and then you can work on number 13. 13 is a pretty complicated one, so we got to work through it. All right, number 11. So let's first, that we want the power of a quotient. So we want to bring that 3 and multiply it to all the exponents on the inside. So 4 and 3 would be 12, and then I have 2 times 3, which would be 6. And then that's my final answer. There's nothing else to simplify. All right, a little bit more complicated. Again, I need to bring this 4 to everything on the inside, including my coefficients. So I have 12 to the 4th and n to the 20th. There we go. And then we can simplify from there. And if they ask you to take it out of exponential form, you could go even further. On your calculator, once you get to like these higher exponents, there's this button on your calculator, okay? And you can click on it. So if you want to do 4 to the 4th power. So with my calculator, I would put in 4, and then it's right under the clear button, to the 4th power. And then you could solve it from there. And then if you wanted to get more complicated, more fancy, so 4 to the 4th power, okay, then you could bring it back down, divided by 12 to the 4th power, and then, oops, I don't want it just for that. All right, to the 4th, and then bring it back down. You want to bring it back down from the powers. And then I could go from there. Oh, I don't want that. So math, fraction. And then they can give me the fancy fraction of 1 over 81 if they wanted that part reduced. Okay, now it's your turn. Try number 13 on your own. All right, guys. So we are on number 12 and number 13. All right, guys. So we had number 12, and we wanted to... Number 12, we should reduce actually when we have that exponent because we can make it smaller. So if we add 4 to the 4th, okay, m to the 8th, and I showed you on the calculator how to do this, 12 to the 4th, and n to the 20th. Okay, so if we take out 4 to the 4th, we can do that on the calculator. We have 256 and then m to the 8th over 20736, so 20,736, n to the 20th, and then reduce this, so you'd have m to the 8th over 81 n to the 20th. Okay, so now I want you guys to try, so sorry to go back to that one. Now I want you to try number 13. Now you need to do this power of a power first, and then do the whole thing. So I kind of will help you out for the first part. Okay. Then we have 4 to the 2nd, a to the 6th, b to the 2nd, and then we need to have this 2nd to everything inside. Then reduce and check back. Alrighty, so for number 13, final answer, 9b squared over 64a to the 10th. So power of a power. Then you were using the quotient by subtracting, reducing, all the good stuff. So that should be your final answer. All right, let's move right along. All right, we're almost through this, guys. So let's get this show on the road. So negative exponent. So if I have x to the negative n, I need to change it to 1 over x to the n. A negative exponent is a no-no in the math world, okay? So we need to move it. Now, let's talk about the other scenario. What if I have 1 over x to the negative m? Well, that means I'm going to bring it back up to make it positive. So the act of moving it changes it from a negative to a positive. All right, a 0 exponent. Anything x to the 0 power is 1. Now, a lot of people have a question on why does this work. So I'm just going to give you a quick example. So let's have 3 to the 0, 3 to the 1st, 3 to the 2nd, and now let's go the opposite way. Why is this the reason? Why is x to the 0 1? All right, so 3 to the 1st we know is 3, and 3 to the 2nd we know is 9. Okay, well, how do we get to the next number? Well, 9 divided by 3 is 3. What is 3 divided by 3? Well, that would be 1, not 0. What if I divided 3 again? That would be 1/3. What if I divided 3 again? That would be 1/9. So that's what makes sense. 3 to the negative first power becomes 1/3. All right, so that's why a negative exponent, we drop it down to the denominator to make it positive. So let's rock these out for me. So 2 to the negative 3rd is 1 over 2 to the 3rd, which would be reduced to 1/8. The next one, I need to add the exponents first. So 3 to the negative 4th, which would then have to drop down to the bottom, 1 over 3 to the 4th. And then what does that reduce to? So that would become 1 over 81. All right. Whoa. Sorry about that. Okay. And next, let's try 16 and 17 on your own. What would you do as the opposite? If they are in the denominator, how do I make them positive? So number 16 would become 36, and number 17 would become y to the 3rd. So they would be brought up to the numerator. All right, we are almost done here, folks. So now we are simplifying. Let me bring this back out. All right, so these are our last problems dealing with negative exponents. So we need to use all of our rules now to simplify. So number 18, we have x to the 3rd and x to the negative 8. So we need to add them, which becomes x to the negative 5th. Then I bring it down to the denominator, and I have 1 over x to the 5th. Number 9, there's nothing on the outside of these parentheses, so I'm going to add them. So I have a to the 3rd and b to the negative 1st. Well, that is not the most simplified answer. I need to bring the b to the bottom. So a to the 3rd over b would be my answer. All right, 20 is my last one. Now I want you guys to try this one. think about what could you move to help you out. So, and what could you combine? So I have my W's I need to look at. I have my X's I need to look at, my Z's, and my coefficients. So how would you solve those separately and get one beautiful answer? All right, your final answer should be negative 4x to the 8th over 5w to the 6th. The Z's went bye-bye. Then that's how we combine. So thank you for joining me on day 7 of Exponents. And please ask questions if you have any. Thank you.